For years, global climate summits have framed the energy transition as a massive, unavoidable penalty. It is routinely discussed as a defensive maneuver, a financial burden that nations simply have to accept to avert environmental disaster. But in India, the math is being calculated differently. Instead of looking at decarbonization as a costly obligation, policymakers and heavy industries are treating it as the largest wealth-generating opportunity in the country's modern history. The country is developing at a breakneck pace, which requires an astronomical amount of energy. Relying on imported fossil fuels to meet that demand drains the domestic economy, leaves the nation vulnerable to global price shocks, and continuously drives up domestic emissions. This chart shows exactly how they plan to solve that math. By systematically shrinking the baseline costs of imported fossil fuels, India is engineering a massive revenue expansion, scaling up to a projected $1 trillion over the next few decades. They are building an entirely new climate economy. To reach that valuation, this economic engine is being constructed upon four specific, interconnected industrial pillars. By approaching climate change as an industrial design problem rather than a penalty, the strategy flips from a burden of reduction to a massive driver of economic growth. The bedrock of this strategy is renewable energy. The country has rolled out massive arrays of solar panels to establish a cheap, abundant, and domestic power foundation. To ensure the power grid remains stable when the sun goes down, vast wind farms stretch across mountainous and coastal regions, diversifying the electrical supply. But standard electricity alone has a limit. Standard solar and wind power cannot generate the intense, consistent physical heat required to run heavy industrial processes like smelting liquid steel or manufacturing cement. While solar arrays and wind turbines are effective for powering consumer homes and light commercial grids, achieving total energy independence requires technologies that can decarbonize heavy manufacturing. This introduces the second pillar, green molecules. By manufacturing high-density energy carriers like hydrogen, ammonia, and synthetic fuels, industries can achieve extreme physical temperatures without burning coal. The third pillar is carbon management. Instead of letting remaining emissions vent into the atmosphere, industrial facilities are installing physical hardware to capture, store, and utilize that carbon directly on site. Domestic companies like Biogenic Urja are taking complex theories and turning them into active industrial practice. They are directly linking the production of green molecules with active carbon management. This visualization shows exactly how their technology operates. Raw carbon waste enters a central node, which splits the stream into two distinct paths. One side yields high-quality hydrogen fuel, while the other outputs stabilized carbon products. By cycling those outputs right back into industrial use, the financial equation changes. Carbon emissions cease to be a waste liability and become a profitable raw material. Integrating hydrogen production with active carbon conversion bridges the gap between basic renewable grids and the total decarbonization of heavy industry. Perfecting these systems locally creates the foundation for the fourth pillar, climate tech manufacturing. Workers and factories across the country are scaling up to build the physical hardware required for the entire global transition. They are moving to mass produce the physical tools of a clean economy, everything from hydrogen electrolyzers and advanced solar cells to massive carbon capture filters. With robust supply chains taking shape, domestic port facilities are preparing to ship these engineered technologies to international buyers. Mastering this final pillar turns a developing nation that traditionally consumed foreign technology into a primary supplier for the global green economy. When renewables, green molecules, carbon management, and manufacturing operate in parallel, these individual pillars converge into a single cohesive industrial ecosystem. Producing dense fuel and electricity locally removes the need to buy imported fossil fuels, effectively guaranteeing national energy independence. This multi-axis chart maps the impact. The simultaneous expansion of domestic power and high-tech manufacturing secures deep industrial competitiveness and technology leadership. As the export growth metric pushes outward, it generates immense capital to fund nationwide climate resilience, locking in a secure economic profile. The resulting landscape is a hyper-modernized industrial society that successfully expands its massive physical infrastructure without degrading its environment. India's climate future is not a story of managing emissions through economic sacrifice. It is a coordinated industrial strategy designed to dictate the global energy and carbon markets for decades to come.